Bismillahirrahmanirrahim. Assalamu alaikum, dear students. I'm Arif and I welcome you all in today's session. To access the course notebook for today's session, you can access course page on my personal website arifpart.me. The other way is to download all the notebook files from course GitHub account RFPUCAT, and all the notebooks for this course are housed in this public data science repository. Well, this is a Jupyter notebook dashboard running locally on my machine at port 8888. And here is the notebook for lecture number 6.22 of the 6th module, Machine Learning, for the course titled Tools and Techniques for Data Science. Well, this is the third session on logistic regression. In the previous two sessions, we did scuba diving into the math involved behind logistic regression. We trained the model using single layer perceptron and also used gradient descent to minimize the cross entropy or the log loss function. Well, the main objective of today's session is to do a scuba dive in the different evaluation metrics that we normally use in classification algorithms. So let's move on to the learning agenda for today's session. My dear students, I will start with performing EDA on the performance heart disease dataset, which we will download from the UCI OpenML repository. We will do a bit of pre-processing on this dataset and then train a logistic regression model on it. After that, we will evaluate the model by using different evaluation metrics like accuracy, precision recall, F1 score, F beta, and ROC AUC score as well. I will do a complete scuba diving and will practically discuss the pros and cons of all these evaluation metrics with coding examples in Python. And finally, I will discuss the hyperparameters of logistic regression model, and I will close today's session by giving you an assignment that will cover complete end-to-end project for binary classification on Titanic dataset. So let me just import all the required libraries and start by downloading the heart disease dataset from the famous University of California, Irvine machine learning repository. And let me first open this link in a browser. The dataset contains 75 input features like age, sex, chest pain type, cholesterol, and so on. That are used to classify whether a person suffers from heart disease or not. The output label has two values, 0 and 1. 0 means the person do not suffer from heart disease, and a 1 means the person suffers from heart disease. These are the details of different attributes. These are the relevant papers that I suggest that you must read. And most of the published experiments, my dear students, refer to using a subset of 13 input features out of these 75. Let me fall back to Jupyter notebook. My dear students, Scikit-Learn provides this fetch _ OpenML method to download datasets from OpenML repository. And for this, you need to pass the name and the version of the dataset. This fetch open method returns a Scikit-Learn bunch object which is similar to a dictionary object, Python dictionary object. Let me just execute this and show you the related keys. You can check out the values corresponding to all these keys for details. And I think I have covered this in our initial session of Scikit-Learn. Let me just create a data frame and display it. Great. So this is the famous heart disease dataset having 303 rows and 13 input features and one target or column label. So we have a bunch of physical characteristics, and this last column, the target column, which is 0 for no presence of heart disease and 1 for presence of heart disease. So this is a binary classification problem. My dear students, sometimes this target label is in a string. That is, it is a categorical variable having strings maybe containing yes and no. In which case you may have to label encode it. Well, this first attribute is the age in years. Second attribute is sex, which is already encoded, 1 for male and 0 for female. This CP is chest pain type. If we just go down and see over here, it is also a categorical feature having 4 possible values 0, 1, 2, 3 and 4, with 0 means typical angina and this 3 means chest pain not showing signs of disease. So there exists an ordering, so that is okay, I think, to have it as an integer encoding. Okay, then we have this resting blood pressure and cholesterol level. This sixth attribute FPS is fasting blood sugar, which is also encoded. Let me go down. FBS. Well, if this is greater than 120, then it is encoded as 1, otherwise it is encoded as 0. Okay. This seventh attribute is resting ECG. Once again, let me check out what does this mean. Okay. 0 means nothing to note, 1 means wave abnormality, and 2 means possible or definite left ventricle hypertrophy. Okay. This THAL-AC is maximum heart rate achieved. EXANG is exercise induced angina. 1 means yes, 0 means no. Then we have old peak, slope, CA, this thallium stress test, and finally we have the output label target. My dear friends, make it your habit that whenever you get a data set, you should have a fair idea of the meanings and the data types of all the columns. Anyways, so given this labeled data set, we need to build a machine learning binary classification model such that given these clinical parameters about a person, can we predict whether or not he or she suffers with heart disease? I hope the objective is clear. Okay, my dear students, once you have imported your dataset, the next step is to get familiarized with the dataset and become a subject matter expert. And since EDA has no set methodology, so there are different ways you can proceed. And we have discussed different tasks that we can normally perform during EDA and data pre-processing in our previous videos. Over here I have mentioned some of the questions that you should ask yourself in this stage, like what is your hypothesis, what is missing from your data and how do you deal with it, are there any outliers and how to treat them, what kind of data do you have and how do you treat different types, how can you add, change or remove features to get more out of your data, and then finally you may like to check out how your data is distributed and the correlation between different variables. Okay, let me quickly do some EDA before proceeding to model building step. And let me first describe the data using the describe method, df.describe. Good. So here are some of the descriptive statistics under the age column over here. You can see that the min max ages are 29 and 77 years respectively, with a mean of 54. 0.3 and standard deviation of 9.08. You can also see the 25th, 50th and 75th percentile. And for the categorical columns like sex, chest pain, and even the output or the target label column, we don't actually really care about the mean, standard deviation, and these percentiles. Uh, I think it's probably better to get value counts for these categorical variables. Let's do that as well. And let me do that on the sex column. Value counts. VALUE underscore counts. Since the male has been encoded as 1, so we have 207 males and 96 females. Let me just copy this, paste this, and check out the value counts for let's say the CP column. So 0 is the case for a typical angina. So there are 143 patients having chest pain due to decreased blood pressure supply to the heart. Okay, and let me check the target column now as well. Change the column to target. And for the target column, 1 means the patient has heart disease, and 0 means the patient do not suffer from heart disease. So this seems to be quite a balanced data set. And of course, you can use a Seaborn's count plot method to visually see this. Let me do that as well. sns.countplot, and let me pass df to the data argument, and let me just use the target column. So here it is. So you see in our data set we have 165 observations or records of heart patients shown by this bar, while 138 records of persons who are not suffering with heart disease. So roughly 54% of the total records are of heart patients. So this is a balanced data set. An unbalanced target column means that one class has far more samples than the other. My dear students, in a similar fashion, you can play around with other columns as well. Let's check out how the data is distributed now under different columns by drawing some histograms. Let me use sns.histplot, and let me use age now. X is equals to age. So seems to be normally distributed with a mean around 55 years. Let's check out the distribution of data under the cholesterol column as well. Let me copy this, just paste this over here, change the column to CHOL. So this is a bit skewed with a mean of around, I think, 250, and this value around 600 seems to be an outlier. Let me check the box plot for this as well. sns.boxplot, data equals df. Let me say x is equal to chol again. Okay. Well, now whether you want to consider these values as outliers or not, you may have to ask a cardiologist, or you can Google out to find more about this. And we have seen as to how we can treat the outliers using trimming or capping. Let me now use the info method of data frame to check out the data types of different columns. df.info. So all the columns are of float type, that is encoding of categorical features is already done. If not, you can use Panda's get dummies method or Scikit-Learn's one hot encoder to encode nominal variables. In case of ordinal data, you can use the ordinal encoder. And if the target column is not encoded, one can use Scikit-Learn's label encoder for that. One more good point of this dataset is that none of the columns has any null values. You can see this over here. You can see the total entries are 303, and for every column we have 303 non-null values. Well, in case of null values, you can either go for univariate imputation using Panda's fill-NA method or Scikit-Learn's simple imputer. I think we have also covered two multivariate imputation techniques in our previous session, which are the Scikit-Learn's iterative or KNN imputer. You can use those as well if you want to. So far, so good. Okay, once again, let's just see the head of our dataset. Let me perform a bit of multivariate analysis as well for completeness. Just let me show you a scatter plot now between let's say this age and this let's say this thal ACH column, which is the maximum heart rate achieved. Let me say SNS dot scatter plot. Pass it to data frame and x equals age, and along the y-axis we keep this thal ACH. Let me just execute. Great. Okay, so let me just add a hue target to identify these dots as heart patient or not. Let me just copy this, paste this over here, and add a hue. Hue equals naturally target. And now let me execute it. Great. This seems better now. It seems that these young people have a higher heart rate. Over here you can see. These orange dots are heart patients, while blue dots represent persons not suffering from heart disease. Let me also show you the correlation matrix now. df dot correlation. CORR is the method of data frame. So this is the correlation matrix. For better visualization, you can always like to see it in a heat map, and we did that as well before. Okay. Let me just say SNS dot heat map, and we have to pass the correlation matrix to this. Let me use annotate equals true. Let me just execute it. Oops. Let me just increase the size of the figure. Let me say plt dot figure. Okay, and let me increase the size to fixed size equals, let's say 15,6. I think this will do the job. Okay, fixed size is equal to, this has to be a tuple. Okay, now this is better. Well, note the ones along the diagonal, because every feature label is perfectly correlated with itself. My dear students, do make time to see and understand as to how different input features are correlated with each other, as well as with the output target label. Okay. I think enough of EDA. This was just a quick recap of the techniques that we have already studied to build an intuition of the dataset. So do spend a bit more time on exploring this dataset as at your own time, and I'm moving ahead. Well, my dear students, we are done with a basic understanding of our dataset. Once you are done with the EDA and data pre-processing task, the next question is, which machine learning model to use for this problem. And since this is a binary classification problem and we have done learning the math behind logistic regression model in our last session, so let's use Scikit-Learn's logistic regression model. Let me just look at our dataset again. Okay, so this is our dataset. Great. My dear students, to keep things simple, over here I'm doing a simple train test split. But I strongly recommend you to do a train test split with a holdout set. So first we need to drop the output label column to get X, and then we are keeping the target column in array Y. After that, as usual, I am calling the train test split method with a test size of 20%. Let me just execute it. So out of the total 303 observations, we have shuffled 242 observations in the training set and 61 observations in the test set. I hope this makes sense. And now let's scale the data, which is the process of transforming numeric columns to a common scale. And for that, I'm creating an instance of standard scalar object and then calling its fit method by passing it the X train. So after this line executes, we have trained transformer object, and the next step is to call the transform method by passing it the X train to get the scaled X train. So the scaled underscore X underscore train contains all the input features scaled and the X test as well. I'm calling transform on the X test as well to get the scaled X test. Well, my dear students, as a side note, remember we call fit on the training data and transform on both the training and the test data. Let me just execute. So we have successfully scaled the 242 rows of training set and 61 rows of test set. Let me show you the scaled data for better understanding. Scaled X train first. Note that all the values are centered around a mean of 0 and standard deviation of 1. Let me verify this as well. Scaled X train, and let me show you the first value, first column, rather the second column. This is the second column, yes. Let me check out the mean. Okay, quite close to 0. And let's check out the standard deviation as well. Quite close to 1. I hope this is making sense to you all. Okay, now let us create an instance of a logistic regression model with default hyperparameters and call this fit method by passing it the scaled X train and the Y train. Let me just execute. So now we have a trained instance and there is a lot of information that we can grab from it, and that we have seen in the previous session as well. Let me just check out the coefficients and the intercept. Model dot coefficient. So these are the 13 weights or coefficients, one for each input feature of heart disease dataset. Let me show you the intercept as well. Intercept underscore. So the intercept, also known as the bias, in this case is 0.178. And my dear students, in logistic regression as well, in most of the classification algorithms, we actually calculate the probability of a data point of belonging to a particular class. And to view the probabilities, you can always use the predict underscore proba method of the trained model. Let me do that and show you that. Model dot predict underscore proba, and we need to naturally pass it the scaled X test. Let me just save this in variable probs and show you that as well. Execute. Great. And since this is a binary classification problem, so it is returning two probability values for each data point. And there are a total of 61 probabilities, as there are 61 data points in the testing dataset. If we consider this first data point, 0.008 is the probability of this point belonging to class 0, that is healthy person, and this 0.99 is the probability of this observation belonging to class 1, that is heart patient. So this first person or first observation, the model will predict that this belongs to the class 1, that is heart patient. My dear students, we normally discard the negative class or class 0 and consider only the class 1, that is the positive class. That is, we consider just the probabilities of each person of belonging to class 1, that is heart patient. Let me just display the second column of this 61 by 2 array. Let me just say probs, select all the rows and just the first column. Okay, so these are the probabilities, 61 probabilities belonging to the class 1. Let me say y underscore prob. Let me say that, save it in this variable. Great. Fine. So this is the probability for first observation of belonging to class 1, probability of second observation of belonging to class 1, and this is the probability of the 61 on the last observation of belonging to class 1. Now we need a threshold value, which is by default 0.5. So all the probabilities greater than or equal to 0.5 are mapped to class 1. Otherwise, they are mapped to class 0. Let me use just list comprehension and do this mapping for you. Let me say 1.0 if the probability P is greater than equal to 0.5, else it should be 0.0, and this should happen for P in y underscore prob. Let me convert this to an array, np dot array. Let me just execute. Great. Let me save it in output for later usage. You can map this. See 0.99 over here we have 1. An easy way to achieve this is to call the predict method, my dear students, on the train model by passing it the scaled X test. Let's do that as well. Let me say model dot predict, and let me say scaled X test, and let me this time save it in y underscore pred, and let me display it as well. Great. My dear students, in case of course, two input features, we can visually plot the decision boundary as well. I can do that over here, I think. We have done that in a previous session. But in this case, heart disease dataset, we have 13 input features, and the decision boundary will be a hyperplane. And of course, that is a bit difficult to visualize and draw as well. Okay, so far so good. Let's move ahead and discuss different evaluation metrics that are used for classification algorithm now. Excuse me. Actually, evaluation allows us to check how well our trained model is performing on data that it has never seen before or that is never used for training. And to check out different evaluation metrics available in Scikit-Learn, we can check the scorers dictionary. Let me show you that. Let me just import from Scikit-Learn dot matrix. Let me just import scorers in all capitals. Let me just say scorers, and this will give you a dictionary of all the Scikit-Learn evaluation metrics. Let me just sort it. Okay, this is better. For classification algorithms, we have accuracy, balanced accuracy, different F1 score measures, different precision measures. We have different recall measures and the ROC AUC scores. Don't worry, my dear students, I will cover most of these in the next 20 to 30 minutes, inshallah. And let me just show you the actual labels of the heart disease test dataset, which are there in y_test. Let me just, this is a series object. Let me just display the values. Okay. And now let me display the corresponding predicted labels. These were the actual or the ground or the gold labels. Let me display the corresponding predicted labels by that is done by our models. And that was, let me do that again, predict, and let me say scaled X test, and we have saved it, I think, in ypret. Let me do that again, no problem. Okay, my dear students, if you compare these two outputs, you can note that the 1, 2, 3, 4, 5, 6, the 6 observations, the first 6 predictions match with the ground labels. These are the ground labels and these are the predictions, and the first 6 of course match. While the 7th observation is wrongly predicted as 1. This observation is wrongly predicted as 1. And similarly, you can compare the rest and compute the accuracy of your model by dividing the number of correct predictions by the total predictions. Okay. Now let me just use this table to acquaint you with the 4 important terms that are used to compute almost all the classification metrics. Well, consider this hypothetical dataset having a total of, let's say, I think 10 observations. And these x1, x2 and so on are the input features, and this column y over here where my mouse is hovering is the ground truth or actual label. This is a binary classification problem, therefore y is either 0 or 1. We normally assign a 1 to the positive class and a 0 to the negative class. And this table above over here shows some of the use cases for binary classification. For heart disease prediction, we assign a 1 to the heart patient and a 0 to the healthy person. In case of email classifier, we assign a 1 to a spam email and a 0 to a not spam email. And for let's say banking transaction, we assign a 1 if it is fraudulent and a 0 if it is not fraudulent. So remember, if there is presence of something, then it is a positive class, and if there is absence of something, then it is a negative class. Most of the classification algorithms like logistic regression gives you the probability of every observation of belonging to a class. So this y_prob column, which I have shown in this table, show you the 2 probabilities. The first value is the probability of an observation of belonging to class 0 or negative class, and this second value is the probability of an observation of belonging to class 1 or positive class. And by default, the classification algorithms consider the positive class, that is this second value shown over here. And since the default threshold value for logistic regression is 0.5, therefore for the first row, This one, first observation, this one, uh, the probability of positive class is 0.255, which is less than zero point 0.5. Hence, y underscore pred column contains a 0 over here. I hope this makes sense. And similarly, for this second observation, since the probability of belonging to positive class is 0.51, which is greater than or equal to the threshold probability of zero point 0.5, hence y underscore pred column contains a 1 for this row. My dear students, please do map the rest of the values under the y pred columns using the same logic. Now, if you consider this y and y predicted column, there can be four possible combinations: a 0 under y and a 0 over here, a 0, 1, a 1, 0, and a 1, 1. Well, this, if we have a 0 over here and a 0 over here, or if we have a 1 over here and a 1 over here, that means the model has predicted correctly. So we name them a true negative and true positive respectively. This first word true means prediction is correct, and this second word tells you the prediction. So in this row 0, 0, we have a true because the prediction has been done correctly. And since the predicted output is negative, so we have a negative over here, true negative. And if you consider this row, whether it is 1, 1, no, it is 0, 0. So the prediction has been done correctly. So we have a true as the first word. And since the prediction is belonging to negative class, so we say true negative. And for this 1, 1, we say true positive because the prediction is 1, so we have positive. I hope this makes sense. So these are the good scenarios, this 0, 0 and 1, 1. These are the good scenarios where our model has made correct predictions, and I have highlighted them with green color. The other two scenarios are where our model has failed. That is this 0, 1, which is shown in orange color, and this 1, 0, which is shown in blue color. This 0, 1 is named as false positive, and this 1, 0 is named as false negative. Over here as well, the first word false means prediction is wrong, and the second word describes the class of the prediction. So false positive. And over here we have false negative. Okay, so these two blue highlighted results are 1, 0. Y is 1 and y hat is 0. Hence we name it false negative. My dear students, these false positives is also called type 1 error. And this false negative is also called type 2 error. For understanding, I just remember that this is 2, and if I put a line over here, this makes it n. So type 2 errors belong to false negative, just for understanding. In this data set, we have just one false positive. That is, a healthy person is wrongly predicted as patient, and there are two false negatives. That is, 2 times our model wrongly predicted a patient as healthy person. So the target is to minimize the type 1 as well as the type 2 errors. Well, I think now we are ready to learn what is known as confusion matrix. Let me move ahead. My dear students, our confusion matrix is a n by n matrix that is used to define the performance of classification algorithms. It is called confusion matrix because it shows the statistics where our trained classification model get confused. And my dear students, please don't worry as it is not confusing for humans. After, at least after this session, it will not be confusing for you as well. Well, this image shows the confusion matrix for the above discussed dataset having 10 observations. Just map, these are the 10 observations having true positives, true negatives, false positives and false negatives. So you just count them up and you can come up to this confusion matrix. Since the output label of the dataset has only two classes, 0 means healthy and 1 means heart patient, so it is a 2 by 2 matrix having just 4 cells showing 4 possible scenarios. Along the horizontal axis, I have kept the predicted label, while on the vertical axis, I have kept the actual or the ground label. I have done this because a Scikit-Learn also use the same format. Well, in literature, you may see the predicted label over here and the actual label along the horizontal axis. And since there are just 10 observations in a dataset, so you can check the values in these 4 cells, that is 3, 1, 2, 4. They sum up to 10 and that is natural. Well, these 2 green cells are the scenarios where our model has predicted correctly. So the first word true is there in both. This 3 in the true negative cell means there are 3 healthy persons who are predicted correctly as healthy by our model. They are healthy as far as the prediction is concerned and they are healthy on ground as well. This 4 in the true positive cell means there are 4 heart patients who are predicted correctly as heart patient by our model. They are predicted as heart patient and they are on ground heart patient as well. Now these blue and orange cells are the scenarios where our model got confused and predicted wrongly. So that is why we have the first word false in both of these. Well, this 2 in false negative cell means there are 2 heart patients who are predicted wrongly as healthy by our model. So these are type 2 errors. And finally, this 1 in the false positive cell means there is 1 healthy person who is predicted wrongly as patient by our model. My dear students, given this table, please see if you can make this confusion matrix. And naturally, for a model to be good, we want to maximize the count of true positives and true negatives while minimizing the false positives and false negatives. Well, to our good luck, Scikit-Learn matrix module provides us these 2 methods, the confusion matrix and confusion matrix display, whose links are shown over here. Let me just click this links. This is the confusion matrix link. Please do read this at your own time. It is passed 2 required parameters, that is y true and y predicted, and it returns a n by n matrix. This is confusion matrix display method. It is passed the confusion matrix itself and it displays it in a nice visual representation. Let me just close these 2 and fall back to the notebook and show you this practically. Let me just use the confusion matrix method and pass it the y-test and y-pred. Let me execute. So we have a 2 by 2 confusion matrix, and for better visualization, let me pass this confusion matrix to the confusion matrix display method. Great. So out of the 61 observations in our test dataset of heart disease, our model has predicted uh, 31 plus 21. 52 observations correctly. This 21 is the true negative count, and this 31 is the true positive counts. This 8 is the false positive, that is 8 healthy persons have been classified as heart patients, type 1 errors, and this 1 is false negative, that is 1 heart patient has been classified as healthy, type 2 error. I hope confusion matrix is clear. Let's move ahead and understand the evaluation matrix now. Okay, let us first talk about accuracy score, which actually answers the question how frequently the model predicted correctly. And the formula to compute accuracy score is the sum of true positives and true negatives divided by the sum of TP, FP, TN, and FN. And this code cell actually displays the confusion matrix. And here I have used the reshape method of NumPy to reshape this 2D array to a 1D array. So you see we have flattened the array. We have now these 4 values, and in this line now what I have done is I have just kept those values. I have actually got the values in TP, FN, FN and TP. So this is flattened, TN, FP, FN and TP. So this is a sequence, and then I have used the formula for accuracy to compute it. It is 0.852, and this is the same which I have computed over here. Great. And remember, accuracy score will be 0 if TP and TN are 0, and accuracy will be 1 if FP and FN they are 0. This is apparent from this formula. My dear students, fortunately, Scikit-Learn matrix module has this accuracy underscore score method, which is passed y-test and y-pred, and it returns the accuracy of our logistic regression model. So great, a perfect match, 0.852. Seems to be a good, reasonable accuracy score. Anyways, let me move ahead and now talk about the accuracy paradox. Excuse me. My dear students, accuracy does not prove to be good evaluation matrix in case of imbalanced datasets, which are very common in real world scenarios. And suppose we have a highly imbalanced heart disease dataset having a total of let's say 1000 observations, out of which 990 are healthy, and they are healthy. Predicted level is healthy, as well as the ground level is healthy, and only 10 are heart patients. And suppose someone designed a stupid or dumb classifier that just classify a person as healthy, which is the majority class in this scenario. And this is the confusion matrix of that dumb classifier. Note that 990 times the classifier correctly predicted a healthy person as healthy, that is belonging to class 0. So true negative is 990. Only 10 times the classifier wrongly predicted a heart patient as healthy. So false negative or type 2 error is just 10. And of course false positive is 0 and true positive is also 0. So my dear students, a classifier that always predicts the majority class in a highly imbalanced dataset will always have a high accuracy score. And therefore, for imbalanced dataset, one should not rely on accuracy alone. You see, the accuracy in this case is just 0.95. That is great. So for imbalanced dataset, you should go for precision, recall, and F1 score. So after understanding the accuracy paradox, let me move on to precision. Okay, let me describe precision now. Well, you can of course click this link to visit the Scikit-Learn's documentation page for details about the precision underscore score method. Let me just fall back to the notebook. Well, consider a dataset containing emails this time. which need to be classified as spam positive class encoded as 1 and not spam negative class encoded as 0. Suppose someone has created two models with their confusion matrices as shown in this image. You can see both the models have an accuracy of 0.8, and the question is which model out of these two is better. If you observe the false positives or type 1 error of model A, it is 30, which is of course greater than the false positive or type 1 error of model B, which is 10. By false positives, of course, I mean actual ham message is wrongly classified as spam by the model. Similarly, if you observe the false negatives over here, false negatives in this blue box, the false negative of type 2 error of model A is 170, which is less than the false negative of model B, which is 190. Over here it is 170 and over here it is 190. By false negative I mean actual spam message is wrongly classified as ham by the model. Now a $100 question is, which type of these two errors, false positive or false negative, is more dangerous for this particular dataset? My dear students, pause this video for a while, think and answer this question. Okay, yes, you are right. In this scenario, this type 1 error is more dangerous. Let me describe this with an example. Suppose the exam staff at our university sent you an email containing your final exam date sheet, which is of course a ham message. But your mailing system has wrongly classified it as spam and has sent it to your spam folder, and you missed the exams. So that means in this scenario, false positive errors are more dangerous. So we will select this model B having less false positives or type 1 errors of 10. Since precision evaluates a model based on false positives, therefore the formula to calculate precision is true positives divided by true positives plus false positives. When we calculate the precision of these two models, the precision of model A comes out to be 0.769 and precision of model B comes out to be 0.909. Therefore, we select model B. I hope this makes sense. And here is the confusion matrix of our heart disease dataset, whose precision comes out to be 0.795 roughly. And note the formula. The precision will be 0 if TP is 0, and precision will be maximum, that is 1, if this FP is 0. And in this code cell over here, I've used the precision underscore score method of Scikit-Learn metric module and passed it ytest and ypred. Let me just execute it. 0.7948, a perfect match. Great job done. Well, my dear students, let me describe the third metric now, and that is recall, also known as sensitivity. We have already seen that precision evaluates a model based on false positives. My dear students, on the contrary, this recall or sensitivity evaluates a model based on a false negative or type 2 error. You can of course click this link to visit the Scikit-Learn's documentation page about the recall underscore score method. Do read it at your own time, and let me fall back to the notebook. To describe recall, consider once again a dataset containing medical history of 10,000 persons, and they need to be classified as cancerous, that is the positive class, or healthy, which is a negative class, that is not a cancer patient. and that is encoded as 0. Suppose someone has created two models with their confusion matrices once again as shown in this image. You can see both the models having an accuracy of 0.9, and the question is which model out of these two is better. Once again, false positive of model A is greater than false positive of model B. By false positive in this scenario, I mean a healthy person is wrongly classified as cancer patient by the model. Similarly, you can observe that the false negatives or type 2 error of model A is less than the false negative of model B. Now the $100 question is the same, and that is which type of these two errors, type 1 or type 2, is more dangerous for this particular dataset? My dear friends, pause the video, think for a while and answer this question. Okay, yes, once again you are right. I'm not going to give you $100. Joke aside, in this scenario, my dear friends, these false negatives are more dangerous. Obviously, if a person is actually healthy, but your model has classified it as rather let me say it like this. If a person is actually a cancer patient, if a person is actually a cancer patient over here, but the model has classified him or her as healthy, and the model has classified that person as healthy. So this is the false negative type 2 error. So there are 200 persons who were actually patient but were predicted healthy by your model A. And over here, there were 500 actual cancer patients which were predicted as healthy by your model. So in this particular scenario, false negative or type 2 errors are more dangerous. So we will select, I think, model A having a lesser number of false negatives or type 2 errors, that is 200. And since recall or sensitivity evaluates a model based on false negatives, therefore you can see this formula over here. To calculate the recall is the true positive divided by TP plus FN. And when we calculate the recall or sensitivity of these two models, the recall or sensitivity of model A is 0.83 while the recall of model B is 0.66. Therefore, we select model A. Great. I hope this makes sense. And now this is the confusion matrix of our heart disease dataset, whose recall score comes out to be 0.968. Note the formula. Recall will be 0 if TP is 0, and recall will be maximum, that is 1, if Fn is 0. And in this code cell over here, I have used the precision_score method of Scikit-Learn's matrix modules and passed it y-test and y-pred. Let me just execute this. 0.968, a perfect match. Great job done. Okay. My dear students, now here comes our real $100 question. We have seen that for the spam email classifier, we preferred precision as evaluation matrix because we wanted to minimize the type 1 error, as we do not want a ham email to be classified as spam. Similarly, for cancer patient classifier, we preferred recall or sensitivity as evaluation metric because we wanted to minimize type 2 errors, as we do not want a cancer patient to be classified as healthy. Now consider another dataset containing images of dogs and cats, containing say 1,000 images which need to be classified as dog as positive class encoded as 1 and cat as negative class, let's say encoded as 0. And once again, suppose we have created two models with their confusion matrices as shown in this image. You can see the accuracy of both these models is 0.8, and the question is, now should we go for a high precision model, that is lesser number of false positives, or for a high recall method, that is lesser number of false negatives? Well, false positive or type 1 error means the model wrongly classify a cat as a dog, while false negative or type 2 error means the model wrongly classified a dog as a cat. So this is a scenario where we cannot, I think, actually make out whether to use the precision or recall. And the evaluation matrix that solve this problem of R is F1 score. So let's understand. Let's move ahead to F1 score now. My dear students, F1 score can be calculated by taking the harmonic mean of precision and recall, which is shown over here, 2 over 1 over Fp plus 1 over R. So remember, F1 score will be high only if both precision and recall are high, and F1 score will be low if any of the precision or recall are low. Well, you can always use the Scikit-Learn's F1 score method to compute it, and this is the code cell that calculates all the 4 metrics for logistic regression model on the heart disease dataset. Let me just execute this. Great. Note that the F1 score 0.87. It is a bit tilted or inclined towards the precision score, that is 0.79. It is not the mean of 0.79 and 0.96. Rather, it is a bit tilted towards this lower value. It is tilted towards the precision, which is lower than recall in this case, and this is because of the harmonic mean. My dear students, you can always use the classification underscore report method that builds a text report showing the main classification matrix. Let me execute. You can compare the accuracy, precision, recall, and F1 scores. My dear students, remember, mostly we consider 1 as positive class, and this is what we have considered in today's session. So you should compare the precision, recall, and F1 score with this row. You can compare these. The classification report also gives you the precision and recall, and as well as the F1 score if you consider this class label 0 as positive class, and this is what is shown over here. And this support is the number of samples on which the metric was calculated, and of course out of all the labels, you can see this is 61, the test. And we will talk about these macro average and weighted average in our next session, when we will talk about the softmax logistic regression. For the time being, just ignore it. And let me move ahead to F beta score. My dear students, this F beta score is quite similar to F1 score, which is actually the weighted harmonic mean of precision or recall. I will not get into the details of its formula. Just remember, if you keep beta equals 1, then F beta score is the same as F1 score. And if you want to give more weight to precision, you pick up a beta value between 0 and 1. And if you want to give more weight to precision, more weight to recall or sensitivity, you pick up a beta value between 1 and infinity. And this is written over here. You can check this out. And in this code cell over here, I've used F beta underscore score method of Scikit-Learn to compute F beta scores using different beta values. Let me just execute it. Great. You can see that for beta equals 1, the F beta score is 0.873, which is the same as the F1 score computed above over here. I hope this makes sense. Great. Okay, so my dear friends, this image describes of what all we have covered in today's session related to evaluation metrics for classification algorithms. I have just created this image. Let me describe it. Uh, First of all, these diagonal values, true negative and true positive, shown in green, is what we want to maximize, and these sum up to 52. 21 plus 31 is 52, and divided by the total prediction, that is 61, give us the accuracy, which is shown over here. I hope this makes sense. And if you see these two vertical rectangular blue boxes, this rectangular blue box and this rectangular blue box, this left one sums up to total negatives predicted by our model, 21 plus 1, that is 22. And this right one sums up to total positives predicted by our model, that is 8 plus 31, 39. If you see these two horizontal rectangular red boxes now, this upper one sums up to total actual negatives, 21 plus 8, that is 21, 29. And this lower one sums up to a total of actual positives, that is 1 plus 31 is 32. Well, in case of precision, we try to minimize the false positives. So you see the formula, we divided TP by TP plus FP. In sensitivity or recall, we try to minimize the false negatives. So you see the formula, we divide TP by TP plus Fn over here. Also note that this specificity over here divides Tn by Tn plus Fp, and this negative predicted value divides Tn by Tn plus Fn. Well, I think that is enough now. There is one last metric that I want to discuss, and that is ROC AUC score. But to give you its crystal clear understanding, let me spend few minutes on the concept of precision recall trade-off. Okay. My dear students, from our discussion so far, you might have observed that if you increase precision, it will reduce recall and vice versa. Now the question is, how can we create a high precision model by minimizing false positives or type 1 error? And how can we create a high recall model by minimizing false negatives or type 2 error? Well, my dear friends, this can be done by changing the threshold value to predict an observation as belonging to a positive class. Let me just walk you through our sample code for better understanding. And let me show you the probabilities of the 61 observations of the heart disease test dataset. Once again, the first column contains the probabilities of the observation of belonging to negative class. And second column contains the probabilities of observations of belonging to positive class, that is heart patient. Over here in this code cell, I just display the column at index 1 containing probabilities of positive class only. And if you see over here, I'm going to create the confusion matrix with a default threshold of 0.5. So I have used list comprehension. For all the probabilities in this Y prob, if their value is greater than or equal to 0.5, I will map it to 1, otherwise I will map it to 0. And then I am using the confusion matrix method, passing it the ground label, that is y test, and this y pred 1, and I'm displaying it. I hope this makes sense. This is the same confusion matrix that logistic regression model is generating, that we have been seeing so far. And that is the default threshold value at that is the logistic regression use, and that is 0.5. And over here, let me increase the threshold value to 0.9 and generate a ypred 2 and pass this ypred 2 to the confusion matrix. Let me just execute. Great. Note the false positives are reduced from 8 to 2. Over here the false positives were 8, and over here the false positives have been reduced to 2, while the false negatives are increased from 1 to 16. And also, if you see, the precision is increased and the recall is reduced. If you compare the precision and recall, you see the precision is increased while the recall is reduced. Let me change gear and let me decrease the threshold value to 0.2 now, and generate a ypred 3 and pass this ypred 3 to the confusion matrix. Oops, let me execute this first and then this one. Great. Note the false negatives are now reduced to 0, and this time recall score has increased to 1 and precision is reduced. Precision is now 0.69, and over here precision was 0.88. My dear friends, this is what precision recall trade-off is. That is, by increasing the precision of a model, its recall score reduce and vice versa. I think now we are all set to understand the last evaluation matrix, and that is ROC AUC score. Okay. My dear students, AUC actually is the area under the receiver operator characteristic curve. Well, we have discussed in detail that by changing the probability threshold value, the confusion metrics change. And in turn, of course, accuracy, precision, recall, and F1 score, everything change. If someone asks you to tell him a metric that is independent of the threshold, then it is the AUC score. Now, a $100 question is how to calculate the AUC score. And for that, we need to understand the ROC, or receiver operator characteristic curve, and which is actually a plot between the false positive rate along the x-axis and the true positive rate along the y-axis, and that too at different probability threshold values between 0 and 1. And you all know that this false positive rate is actually the probability that a negative sample is incorrectly predicted in the positive class, and it is equal to Fp divided by Fp plus Tn. And this true positive rate is the probability that a positive sample is correctly predicted in the positive class, and is equal to Tp divided by Tp plus Fn. My dear students, this graph over here shows 3 different ROC curves of 3 different models. The AUC score of each model is actually the area under the respective ROC curve. Well, this blue line, or this blue ROC curve, has 50% of the area under it. So its AUC score will be 0.5, which means that this classifier is just randomly predicting. Not good at all. This pink ROC curve covers more area, so it is a good model. And this orange ROC curve covers the maximum area in this case, so it is better than these two. The more is the AUC score, the more efficient the model is at at distinguishing between the positive and the negative classes. Okay, let me show you with this dataset, toy dataset. Let me describe how you can plot an ROC curve for this dataset, having just 4 observations shown in this table. My dear friends, this column Y shows you the actual label, while this H of X is the column containing the probabilities of that observation of belonging to positive class. And you see for a threshold of 0.3, this 0.3 is mapped to 0, while the rest of the probabilities are mapped to 1. I hope this makes sense. Similarly, for a threshold of greater than 0.5, the first 2 observations, these 2 observations, 0.3, 0.5, they are mapped to 0, and the other 2 are mapped to 1. And finally, for a threshold of greater than 0.6, the first 3 observations are mapped to 0 and the last one is mapped to 1. I hope this makes sense. I think you can easily map these TPs, TNs, FPs and FNs as well. I have also calculated the FPR and the TPR for each threshold value. For 0.3 threshold, the TPR is 1, FPR is 0.5. For 0.5 threshold, the TPR is 0.5, FPR is also 0.5. And for 0.6 threshold, TPR is 0.5 and FPR is 0. So we have FPR, TPR for every threshold. And when I plot these FPRs and TPRs, this is the ROC curve. And if I somehow calculate the area under this curve, it is the AUC score. I hope this makes sense. Okay. Let me just display the probabilities now and calculate the AUC ROC score for the heart disease dataset. Let me just execute this. So these are the probabilities, 61 probabilities of belonging to the positive class. I am just displaying the second column. And over here in this code cell, I'm using Scikit-Learn's ROC underscore curve method and passing it the Y test and the model probabilities, and it returns FPR, TPR and the threshold. Just do go through the help page if you want to go for the details. And over here I'm just displaying these values as a data frame so that you can have a fair understanding of it. You can see this is a threshold value, and for this threshold value the FPR and TPR has been calculated like this. And finally over here in this code cell I am using Scikit-Learn's ROC underscore AUC underscore score method, and it will return me a float value representing the area under the ROC curve. I'm also using the matplotlib's plot method to plot a line by keeping FPR along the x-axis and TPR along the y-axis. I hope this makes sense. Let me just execute it. Great. My dear students, the more this ROC curve hugs the top left corner of the plot, the better the model does in predicting data points to correct classes. And this AUC score actually quantifies it, which for our logistic regression model on heart disease dataset comes out to be 0.94. And I think that is it about the evaluation matrix. Before closing today's session, let me just quickly give you an overview of hyperparameters of logistic regression. My dear students, I took a complete separate session on hyperparameter tuning. I think that was 6.15 while we were talking about the ridge regression, I think. You all know that every machine learning model has its own set of hyperparameters which need to be specified when you create the instance of the model before training. And if you want to check out the model parameters, you can use the get params method and call it on that specific machine learning model. Great. So there is a whole bunch of hyperparameters. that you can use for logistic regression, and these are their default values. And for the details of these, you can always visit the Scikit-Learn's documentation page. So there is a whole bunch of information about all these parameters, and I have discussed these in detail. If you go through them, I think you will be able to understand it. Please make time and read about these hyperparameters, using which you can customize your model by tuning these knobs, these penalty knob, regularization penalty, this fit intercept, whether you want it or not, these solvers, the optimization techniques. Let me just fall back over here. Well, in order to find the best combination of the hyperparameter values, we have used the grid search and the randomized search with cross validation. Please do this at your own and see if you can improve the performance of logistic regression model on the heart disease dataset. And so we are done with today's session, and here is an assignment for you to do. Let me just load this Titanic dataset from UCI OpenML repository in a pandas data frame. Let me just execute. Great. That dataset has 1309 rows with 13 input features and one output column. And I think we have discussed this dataset in many of our previous sessions before as well. It shows the information about the Titanic ship that sank in North Atlantic Ocean in 1912 after striking with an iceberg. And this is very famous dataset used for classification. You can see the output label target with two possible values. A 1 means a passenger survived and a 0 means not survived. My dear students, I want you to carry out a detailed analysis, univariate as well as multivariate, of different columns of this dataset by using different appropriate charts of Matplotlib and Seaborn. You should perform pre-processing on this dataset, like handling outliers, imputing missing values, encoding categorical features, scaling the features if required. And last but not the least, you may like to do feature engineering as well by dropping unnecessary features from this dataset. And once the data is ready to be fed to the machine learning model, you should do a train test split, rather better to perform k-fold cross validation. In the first iteration, you may train and evaluate a non-pipelined model and do hyperparameter tuning using grid search and randomized grid search CV to get the best evaluation result. And once satisfied, you should create a pipelined version of this model. And finally, you should save the model in a pickle file and deploy your model on cloud using Streamlit or maybe Flask. Well, a chocolate for the student whose model gives the best result. Okay, my dear students, that is all for today's session. I think it was informative for you all. If it is, please subscribe my YouTube channel and share it with your friend. I wish you all the best. Happy learning and Allah Hafiz.